Hello dear students, welcome back to my YouTube channel. I guess I am audible and visible to you. I guess that I am audible and visible to you. Let me check. So, as you know that we completed AC yesterday. From today onwards, we will be starting EM waves. This chapter will take probably 2 lectures or 3 lectures. That means from Monday or from Tuesday or from Wednesday, we will be starting modern physics. Okay, today lecture number first, Monday lecture number second, and if in some cases, hello beta, if in some cases we need to extend the class, that means Tuesday up to Monday or Tuesday we will end the EM waves. From Tuesday or from Wednesday we will start modern physics. Okay, and this one is very simple chapter with simple numericals. Okay, you don't get any difficult thing in this particular chapter, right? Very easy one. You can manage the chapter within some formulas. Yeah. So now let us start our journey with EM waves. So starting the first lecture of EM waves. EM waves known as electromagnetic waves. So today we will be starting EM waves, also known as electromagnetic waves, or sometimes you will find simply EMW. So now we will discuss one by one its property. These are non-mechanical waves. These are non-mechanical waves. Non-mechanical waves means they don't need any medium. They do not require any medium for wave propagation. For wave propagation. Just like, look, we are having sound waves, right? We are having sound waves. Sound waves, they do require. These waves do require medium to travel. Sound waves do require medium to travel. So these waves are known as mechanical waves. But in different way, we are having non-mechanical waves. Non-mechanical waves are those waves which do not require any medium for their propagation. Okay, and if you want to take the example, EM waves. EM waves is the example of non-mechanical waves, just like light. Light comes from sun. Light comes from Jadhav ji. Hello beta. Look, light comes from sun, and we know that from sun to earth there are a lot of things between sun to earth, right? We don't have any medium in between. Then we are having medium. So my light travels in medium. Also, when there is no medium, light travels in medium or in not any medium, in vacuum also. So light is a non-mechanical wave, you know. So second property, in vacuum, they travel with the speed of light. With the speed of light, that is 3 10 to power 8 meters per second. If we talk about vacuum, the equation is C equals to 1 divided by under root of epsilon naught mu naught epsilon naught. Okay, what is mu naught? Permeability. What is mu naught? It is permittivity. Done. 4 pi 10 to the power minus 7, 8.8 10 to the power minus 12. When we are placing the values, we approximately get the value of 3 10 to the power 8 meters per second. But when we will talk about the medium, epsilon naught, we need to write it as a epsilon naught epsilon r, and mu naught as a mu naught mu r. So then the equation came out to be C dash, or I can write V only, So V becomes now 1 divided by under root of epsilon naught, mu naught mu r, epsilon naught epsilon r. So it could be equals to C divided by under root of mu r epsilon r. We can write in this way. And this expression was asked in the NEET examination. This expression. You can see how simple numericals you will get from your NEET examination. This was asked in your NEET examination. This dabba thing, this box thing. Okay? Easy or super easy? Easy or super easy things? I guess super easy things, right? You will get numericals from the EMW in this only way. It is not a very big chapter. It doesn't have that much of high conceptual things in it, right? Now, if we talk about now refractive index. If we talk about a refractive index. A refractive index means Ri. I guess refractive index is speed of light in vacuum divided by speed of light in medium. So I can write C divided by under root of mu r epsilon r, which came out to be under root of mu r epsilon r. These are some equations that you need to write, you need to remember for your examinations. Directly you will get a numerical like this in your examination. You need to write these things. So refractive index is equals to mu r epsilon r. Done? And in maximum cases, we are taking mu r equals to 1. Do you know why? Because we consider both are non-magnetic materials. If nothing is given to us, we need to consider mu r as 1. If nothing is given to us, we need to consider mu r as 1. Why? Because non-magnetic substances. One more property that is, in electromagnetic waves, electric field vector and magnetic field vector are perpendicular to each other, and also perpendicular to the direction of Wave propagation. Wave propagation. That means if light is going in x direction, if any electromagnetic wave is going in x direction, and that simply indicates my electric field vector should be in y and my magnetic should be in z direction. Both should be perpendicular to each other and both should be perpendicular to the speed of the light, that is the propagation of the light. So it simply indicates that, look now, I will show you this thing by visualizing, okay? But I guess there is no visualization present now. So no worries. No worries. Look now. We know it is I cap, J, and K. If I is direction of propagation, Y as electric field vector, K as magnetic field vector. This is how you need to show your electromagnetic wave. And what is E cross B? If you are doing E cross B, it will give you direction of propagation of wave. Propagation of wave. Done? Easy, no? Easy? Or you can write speed is equals to E naught by V naught, or equals to ERMS divided by BRMS, and ERMS equals to E naught by root 2. BRMS equals to B naught by root 2. These things we discussed in the AC chapter. That's why I told you these chapters are interlinked. AMI, AC, EM waves, right? One more thing. You can see now, if this is my propagation of light or wave, here is my, look, this wave is electric field vector. This one is my electric field. You need to notice this one, no? This one means electric field. Look now. And this one is my magnetic field. Okay. So now, what is the reason that I show you this diagram now? This diagram is very important. It states that, or it shows that, look, it shows that electric field vector perpendicular to magnetic field vector, or you can write E cross B will give you direction, and E dot B is equals to 0. Then one more thing, that no phase difference. There is no phase difference. Do you know why? Look now, I will show you. Look, it starts from 0, both starts from 0. Here it is at maximum level. At the same time, this one is at maximum level. 0, 0. Then max level, then 0, 0. So both electric field as well as magnetic field are going with the phase. Both are at zero, both are at peak. Both zero, both peak. Peak, zero, peak, zero, peak, zero. That means, yes, they do have 90-degree angle between them. But they are getting 0 degree same time and 90 degree same time. There is no issue, no? There is no conflict between the phases. So the phase difference is 0. So phase difference is 0. Furious Gaming, sir, are you Kashmiri? Yes, but I am Kashmiri. I guess my student knows that, not that I am from Kashmir. They know it. Done? Easy or super easy up to this level? Easy now? And I am writing each and everything that you need to note it down. If you are not able to note it down right now, so after the class, I am sharing the PDF of my notes to your Telegram group. So you need to just join the Telegram then. Yeah, I am a Koshur, right? Bachpan se I am Koshur. Okay. Look now. So let us discuss the new property of EM waves. Basically, EM waves, these are transverse waves. Transverse waves in nature. If we talk about between transverse wave and a longitudinal wave. Longitudinal wave. Look here. This particular thing is the notation of the transverse wave. That means particle is going up and down, up and down, up and down, and wave is going towards the right direction. So this direction shows this arrow, no? Wave propagation. Wave propagation. And this direction shows particle motion. This means particle motion. Okay. And whenever we are having transverse wave, there is a property known as polarization. Polarization. Polarization is a topic in our optics. So here I won't just discuss what polarization means that, but here I will give you a little bit of hint now that transverse wave do follow polarization, but longitudinal waves doesn't. One more thing, what is longitudinal wave? Longitudinal means if it is my particle, it will go back and forth. It will go back and forth. Example of my longitudinal wave, just like sound wave. Sound wave is the kind of longitudinal wave, and EM wave is a type of transverse wave. Type of transverse wave. Done? Next property. EM waves carries energy and momentum. So you will find how momentum transfer takes place here. EM waves. One second. Yeah, EM waves carries energy and momentum. So how we will produce the EM waves? By accelerating particles. If my particle is in the accelerating mode, so we will get EM waves. And if you are present in my classes with your open minds and open eyes, in the first lecture of electrostatic, we discussed if the particle is at rest, only the electric field is associated. If the particle is in motion, uniform motions, electric field and magnetic field both are present with the uniformity, right? Third one, if the particle is in motion, but the motion is a non-uniform accelerated motion, there will be an electromagnetic wave. So if the particle is in acceleration motion, there will be an electromagnetic wave production. Done? Easy? Okay, now if we talk about the equations, we are having two equations here. Y, or one equation, A sine omega t minus kx, or you can write y equals to A sine kx minus omega t. Both equations are same, but phase difference is different, right? So look now how we need to understand these two equations. So look here, look here, look here, look here. So if you need to find direction of propagation, if you need to find out direction of propagation, okay, for positive or for negative, see the symbol, if same symbol, if same symbol. Now here, one second, if positive is there, if different, if negative, if same symbol, same symbol. Look here, first of all, what is written here? Sir, x. So that means these two waves will go in x direction. These two waves will go in x direction. So x is now confirmed. Now we have 2x minus x and positive x. So whether the wave will go in positive or negative x. Now you can see second step. Look here. What is the sign of omega x? It is positive. What is the sign of kx? It is negative. Different now. So if you are having different, it will go towards positive one. So the positive one. One more equation, y equals to A sine omega t plus ky. Now this one just give me the answer propagation. Sir, first of all, it will go towards the y. Then positive y or negative y? Positive or negative y? Now you can see this one is also positive. This one is positive. Positive means same. So if these are same, so it will go towards the negative axis. It will go towards the negative y. So this propagation is towards the negative y. It will go towards negative y. Then let us do some, let us understand the equations now, right? So look now, what is omega? What is omega here? Sir, omega means angular frequency. Angular frequency, which is equals to 2 pi f. So what is k now? Wave propagation constant, or wave propagation constant equals to 2 pi by lambda. 2 pi by lambda. So you can see here omega is angular frequency, which is equals to 2 pi f. K is wave propagation constant, which is equals to 2 pi by lambda. You need to learn, or you need to memorize these formulas, each and every one. You have to memorize each and every formula from the EM waves. You will find couple of formulas now, but they are very easy to you. Very easy. Okay. Look now. Okay. One second. This is my equation or my question in front of the screen, and you need to do this question. In an electromagnetic wave in free space, the root mean square value of the electric field is 6 volt per meter. 6 meter per meter. Peak value of the magnetic field is. And I hope that you can do this numerical, and I will wait for 1 minute so that I will give you time. I will give you a time for this one now. You can try it now. Very easy. Very easy now. So I guess you have noted down this one. I will show you. Sir, what we have to find out? The peak value of magnetic field. So peak value of magnetic field, that is B naught. B naught is equals to B R M S under root 2. Why? Because B R M S equals to B naught divided by under root 2. But we don't know what is BRMS. But we know one formula, C equals to E by B. It is ERMS divided by BRMS. What is C? 3 10 to power 8. What is E? 6 divided by BRMS. Look now. So BRMS equals to 6 divided by 3, 10 to power 8, 3 1 3, 3 2 6. So my answer came out to be 2 10 to power minus 8. Place the value here now. So it came out to be 2 10 to power minus 8 multiplied by 2. 2 multiplied by 2, it came out to be 2.83. I guess 1.4 into 2. 4, yeah, 2.8, 2.8, 10 to power minus 8. Tesla. Option number A is correct. You can cross check the answers. You can cross check the answer now. I hope it is very easy and very simple to you. You can take the screenshot also, right? If you want, you can take screenshots also. 1 second now. 6. Now let us discuss one more numerical. One second. Second numerical. Second numerical. Give me 1 second, beta. So let us start now. Okay, there is some problem with some electricity. 1 second, 1 second. There was some problem with connectivity. I guess now everything is sorted. Okay, look now. Am I audible and visible? Now let us continue, but drop a network. No worries. Question is the electric field which is associated with an EM wave in a vacuum is given like this. Okay, electric field is given to us like this. The value of wave vector, that is k. So we have to find out k. So do you know that there is one more formula that you need to remember, that k is equals to 1 second. It would be equals to omega by v. Omega by v. Okay. Now you can see this formula. this formula. Is it kz minus omega t? What is omega? So omega is secant 10 to power 8. What is v? Is v given to us? 3 10 to power 8. Cancel out 2. I guess my answer is 2. Yes, sir, my answer is 2. So it is 2 per meter. So my answer is 2 per meter. Easy numericals, only this numerical you will get in your examinations. Okay, this one now. Easy one, simple one. So numerical is the magnetic field in a plane. Electromagnetic wave is given by this much 2 10 to the power minus 7. So this one is my A and K omega. So I can write it as kx plus omega t. We have to find out wavelength. Wavelength is k, that is 2 pi by lambda. Okay. So what is k now? So we have to find out lambda. Lambda is equal to 2 pi by k. 2 pi. What is k now? K is pi 10 to power 3. Cancel out. So I guess my answer 2 10 to power minus 3. 10 to power minus 3. Simple numericals. Very easy numericals. These numericals don't take much time to get these things done, right? Okay, next numerical. Okay, a big one now. Okay, this numerical now. So first of all, numerical is we are having an electric part of EM wave. It is 0. EY is this much and EZ is 0. Now, look now. This one is in positive. This one is in negative. So first of all, my X, propagation would be in positive X. Look, cancel out, Y cancel, positive X, it could be done. Now, frequency is 10 seconds, so there is no fun of finding frequency. Let us find wavelength now. What is wavelength now? Sir, k equals to 2 pi by lambda. So lambda equals to 2 pi by k. 2 pi by k. It is kx now. So I can write 2 pi by k. So what is k? K is pi 10 to power minus 2. Cancel out. It is 2 10 to power 2. That means it is 200. 200 means option number 4 is correct. Easy now? Option number 4 is correct. You can see now. You can do this question from your own end and you can just drop the comments which one is. If I had made any mistake, now you want to correct my mistake, right? You can just comment below. So no, it is not in this way, or you have to follow this particular techniques to get it done. Okay. Now next one. The class will take only half an hour more. Then we are done with today's section. Okay, next one. This one done. This one done. This one done. Okay, now this one now. This one now. The magnetic field in a plane, electromagnetic wave is given by this much. What is the wavelength and frequency of the wave? Okay, wavelength. Frequency. Then wavelength means lambda. Frequency means f. We have to find out lambda and f. So this equation I can write B equals to A sine omega t plus kx. But here I will just rearrange this. I will write kx. It is kx plus omega times t. So B equals to 2 10 to the power minus 7 sine k. K is how much? 0.5 10 to the power 3x plus 1.5 10 to the power 11t. Now, what is omega? Omega came out to be 1.5 10 to power 11. Omega is 2 pi f. 2 pi f is 1.5 10 to power 11. F came out to be 1.5 10 to power 11 divided by 2 pi. Pi is 3.14. Done? Look, 2 0.75. I can add 0.75 divided by 3.14. 10 to power 11. Rest calculation you can do from your end, right? Cancel out, cancel out. So I can write 75 divided by 314, 10 to power 11. 75 into 4, 0.4. 0.4, it is 0.48 something, no? It will be like this. Yes, I guess it will be like this, no? You can do the calculation, no? You can do the calculation, you will get the answer. Not big deal. Second part is frequency is done. Now wavelength. It is wavelength, that is k equals to 2 pi by lambda. Lambda is 2 pi by k, and it is 2 pi. What is k now? K is equals to 0.5 10 to power 3. So cancel out, it is 10 here. It will be 2 pi by 5. Then 5 on the 5 to the 10, 2 to the 4, 2 to the 1 second beta. 5, 10, 4, it is 4 pi 10 to power minus 3. Expression for electric field. First of all, where my electric field will be? Look, we have lambda now. So we need to find direction only. Only now direction. So look here, positive, positive, and x, it will be in negative x. What is E naught? It will be CB naught. What is C? 3 10 to power 8. B naught. What is B naught? Is it given to us? 2.7. It is 2 into 7. It is 2 into 10 to power minus 7. 6 is 10 to power 1. 60. So E came out to be E naught sine omega t plus kx. So yes, this is my equation. This one is the equation, no? Done. So now let us start one of the most important topics. Most important, that is displacement current. Displacement current. Suppose we are having a system. We are having a system. What we notice that whenever we are placing the key close, key is closer, the current I will go from the battery and I will go inside the battery. So here I will get charge Q, I will get minus charge, right? So this side plus charge, this side minus charge. If current is flowing, so we know that by Ampere is law, so this current which is flowing through it, there will be a magnetic field outside. So we place a magnet here or a compass. This compass shows deflection. If compass shows deflection, so this is present. Look here, current I is flowing. Now make a Ampere circuital law loop, right? So here B is also present. Now third step is we place a compass here. We place compass here. Now what we got here, the compass shows deflection. This compass shows deflection. That means inside also, what is there? B is present. So what is the cause for B? What is the cause for B? Look now, when current is flowing, when current start flowing, there should be a charge accumulation. There is charge accumulation, and the charge accumulation on the sides of the capacitor will give rise to the electric field. And this electric field is changing. And this electric field give rise to the magnetic field. This magnetic field, we know from EMI, magnetic field give rise to the electric field, but here we conclude that electric field give rise to the magnetic field. Now, according to the KCL, if current is coming to the loop to the circuits, so according to the KCL, if current I is flowing through it, so there should be a current leaving. Okay, so this current which is flowing through the coil, through the wire, current which is flowing through the physical quantity wire, it is IC, conduction current. And the current which is hypothetical inside the capacitor, that is my displacement current. So what is IC now? IC means it is conduction current. Conduction current means the current which flows through the wire. And displacement current means it is a hypothetical current which we assume that it gets produced when the changing electric field gives rise to the magnetic field. So we are having displacement current. Okay, and one thing that is the current, conduction current is also equals to displacement current according to the Kirchhoff's current law. Then Kirchhoff's current law. And if my incoming thing is AC now, we are not dealing with DC, we are dealing with AC now. If V equals to V naught sine omega t. So we know that V R MS equals to I R MS into XC. So I R MS equals to V R MS divided by XC. And we know that I R MS equals to I naught by root 2. We know it. We know these things, and you must know what did I wrote upside. So from all these conclusions, we know that IC equals to ID. Where IC is present, ID is 0. If IC is not equals to 0, then ID is equals to 0. If IC equals to 0, then ID is not equals to 0. So you will write total current, summation of current is equals to IC plus ID. Then look now, one more time. If V equals to V naught sine omega t and charge is Q, right? So what we know that ID equals to C dV by dt. We know it. ID equals to C d by dt. What is V? V is V naught sine omega t. Look, ID, C V naught is outside. It will be cos omega t into omega. So ID equals to C V naught omega cos omega t. C V naught omega cos omega t. Or if you want more derivational part, so I will show you the more derivation from the chapter. So set up first, E equals to sigma by epsilon naught electric field due to the capacitor. What is Q? Sigma is Q by A epsilon naught. What is phi? Is electric flux. Okay, it will be E into A. What is E? It will be Q A divided by A epsilon naught. Done. So cancel out. So I will got K divided by epsilon naught. Done now. So phi E came out to be Q by epsilon naught. So Q equals to phi E epsilon naught. So what is current? Current is dQ by dt. I will just differentiate it. So d by dt phi E times epsilon naught. Okay, and differentiated. I equals to epsilon naught is constant d phi dt. This is how you will find your displacement current. One more thing, we know that Q equals to CV. Differentiate dQ by dt equals to d divided by dt into CV. This will become I, and C is outside, it will be dV by dt. One more expression for calculation of your displacement current. Easy or super easy? Huh? Easy or super easy? Due to now, I can understand now there is some sort of network issue at my place, but still I am trying to give the best things. So in this particular chapter, we conclude that what EM wave is basically different forms of EM waves, different properties of EM waves, then some numericals, then displacement current and displacement current equations. In next class, we will be doing the numericals from displacement current, then Poynting vector, dense energy densities, moment transfer, right? So in next class, I hope that I will end the whole class and let us hope for the best. And thank you, Beta. Thank you very much from my side. If you're having any issue or anything like that, you can just comment below, or you can just share your thoughts about the class. Okay. I guess I am giving you to the point knowledge, everything that is required to you.